Hi guys, welcome back. It's Professor Hank, and in this video, I'm going to talk to you about C++ Bitwise operations. So we're going to go into the Bitwise operators: shift left, shift right, Bitwise and, Bitwise or, Bitwise exclusive or, Bitwise not. So these are all operations that occur at the bit level. I mean, I suppose you could say that all operations occur at the bit level, but these are operators that you use specifically with bits in mind or in mind, okay? And very useful for a lot of different things for efficient storage of information. You see these types of operations done in systems programming, for example. So let's go ahead and dig into it. So in order to understand how these operators work, we're going to have a little bit of a review on data stored in a computer, right? So let's assume for a second that we're working with a character data type. And so why am I saying a character data type? Because a character data type in C++ has got 1 byte. So how many bytes are there, or how many bits are there in a byte? There's 8 bits in a byte, right? So it's a little bit easier to work with for demonstration purposes, but this holds for any other data type as well. You know, any other primitive like ints or shorts, for example. Okay, um, so if you have a character data type, okay, what you have is you've got uh, 8-bit positions, right? Was that 1, 2, 3, 4, 5, 6, 7, 8? Okay. Now each one of those positions corresponds to, they're either 1 or 0. Okay, and so each position corresponds to a place. Like in base 10, you've got the ones place, the tens place, the hundreds place, the thousands place. Well, in binary, you've got the ones place, you've got the twos place, you've got the fours place, the eights place, the 16ths place. So I should maybe write this like this. Okay, the 16ths place, the 32nds place, the 64th place, and then you've got the 128th place. Okay, so the way you encode a number is that anywhere that there is a 1, right? So let's say that there's a 1 here and there's a 1 here, and then everything else are zeros. Okay, so if that is the bit pattern that's stored in this character variable, then what's actually being stored there is 9. Okay, and some of you may or may not know that a character variable in C and C++, yes, it's for storing characters, but it's also an unsigned integer, okay, that can hold from 0 through 127, which normally represents the ASCII code for a particular character. But for this, like I said, for this demo, we're using the character data type just so it'll be easier to deal with all the bits. Okay. Oops. Let's get that out of there. Okay, and fix that. Okay, so let's go ahead and create a character variable. I'll just call it C. Okay, and then I'll initialize it with 9. Okay, so if I do that, that means that my bit pattern is going to have 0 128ths in it, 0 64, 0 32nds, 32s in it, 0 16s, 1 8, 0 4s, 0 2s, and 1 1. So that is going to equal 9. Okay, so now there's all these different operations that I can do. Okay, so you've got shift left. Okay, you've got shift right. You've got bitwise and. You've got bitwise or. You've got bitwise exclusive or, and then you've got bitwise not. Okay, so we'll go through each one of these to demonstrate how they work. Okay, now you're looking at the, let me go ahead and minimize this here. You might be looking at the C and going, you signed 9 to it, what? You can even see it, if you can maybe see it in the over, when I moused over it. Now, of course, it's not popping up, but where'd it go? I had it for a second. There it is. So you can see there's the bit pattern that I was talking about, right? Okay, so if we were to cast the C as an int, okay, and I was gonna run this for you, you wouldn't see anything unless I was in Visual Studio 2022. If you were in an earlier version, the window would just open and close, but later versions of Visual Studio keep the window open for you automatically. But my point is that you can see the 9 there, right? Because that's what's actually being stored in the character variable. Okay, and if I didn't cast it as an int, it's almost certainly not going to show you anything. Yeah, because the ASCII code, the character with ASCII code 9 is a non-printable character. Okay, but anyway, so that's what's in there, right? So now let's take a look at that very first character. We'll go with shift left. Okay, so what does shift left do? All right, so if I take some variable C, okay, and then I use the shift left operator, which looks just like one of the stream operators, right? Looks like the stream insertion operator, okay, but we're repurposing it here. So if I say 2, okay, so what this does is this takes this bit pattern and shifts everything 2 positions to the left, okay? Now, I'll go ahead and just take the result of that operation, just like if you said 2 plus 2, the result is 4. And I will overwrite it. I'll overwrite what's in C with that. Or maybe I should do a completely separate variable just so it's not as confusing. That's what I'll do. Okay, I'll say char D is equal to C shift left 2. So what's going to end up in D? Okay, well, I'm going to show you. Okay, what's going to end up in D is going to be the bit pattern with everything shifted 2 positions to the left. So this one right here is going to move into 2 positions to the left here, and then this one is going to end up 2 positions to the left here. So let's just go ahead and do that. So 1, 2, okay, and then this one, 1, 2. Okay, so what number is that going to be then? Well, let's go back and look at our little table here. So now we know we've got the 1 in the 4's place. That's right here. So it's a 1, 2, 4, 8, 16, 32. So 32 plus 4 is 36. Okay, so now if I do the C out D thing and cast it as an int, D, okay, then what we're going to see is we're going to see 36. Okay, because again, we shifted those bits over. So this integer here, in this case I use 2, but that's just how many places to the left that you're going to shift it. Okay, now that's how shift left works. Now what about shift right? Okay, that's that operator. So what I could do is I can say, we'll go ahead and just stick with the C again. Let's shift right 1 position, okay, and then we'll put that in D. And then we'll C out D again. Okay, well, what's that going to do? Now remember, this is what was in C originally. We didn't change that. Okay, what we did is we did a shift, and this resulted in there being a new number, which we then assigned to D, right? Now what's that new number going to be? Okay, well, if we shift everything to the right by 1 place, this one right here is going to move here. Okay, and this one right, oops, that should be a 1 or a 0, excuse me. Now this one right here is going to shift to the right, but there's nothing to the right of the 1's place, so that just falls off. So then this is going to be 1, 2, 4. So this is going to become 4. Okay, so D is going to end up with 4 inside of it. Okay, so you can see there's the 4 right there. Now maybe I should have put these things on separate lines so it's easier to see. So I'll do that right now. Okay. So let's go ahead and run that. So see, there's the 4. So you got to kind of understand what's happening at the bit level to figure out what's going on here. Okay. Now let's take a look at bitwise and. Bitwise and. Okay. So when you have a bitwise and, this is what happens. Right. So with and, what you do is you have this little table, right? So 1 and 1 is equal to 1. So it's kind of like true and true is true. Okay. True and false is false. False and true is false. And then false and false is false. Just like with the regular logical and, right? But at this point, or in this case, it's with bits. So we can see that C has got, this bit pattern in it. That's never changed. So if we were to do something like this, C and, let's see, C and 7. Okay, and we'll put that in D. Okay, what are we going to end up with? Okay, well, 7 is this. Okay, that's 7. Okay, with all leading zeros. Okay, so what you do is you go position by position. So 0 and 0 is 0. So the result of that position in the new number is going to be 0. 0 and 0 is 0. So the result of that position is going to be 0. Matter of fact, let me maybe make this a little bit more clear. Okay, if you take these two numbers, you AND them together. Okay, you're going to end up with a new number. And you just go, like I said, position by position. 0 and 0 is 0, 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 1 and 0 is 0, 0 and 1 is 0, 0 and 1 is 0, and 1 and 1 is 1. Okay, so the number that's going to end up in D is going to be 1. So let me delete that, and I will prove that to you. Okay. So there is your 1. Okay. Now, what about the OR? Okay. Now the OR, let's say I was going to do C OR 7. Okay. Now the way that works is that if either of the bits is 1, then the new number is going to have 1 in that position. So 0 or, let's just start with 1. 1 or 1 is 1. 0 or 1 is 1. 1 or 1 is, 1 or 0, excuse me, is 1. Okay, but 0 or 0 is 0. So the only way you get a 0 out of that is if both of them are zeros, right? So if I take what was in C, okay, remember what was in C? Maybe I feel like I should comment these out just to get them out of the way. So I think I'm going to do that. Okay. I could fold them in and get them out of the way. Okay. So if I was to take that 7 again, okay, 1, 1, 1. Okay. The new number that I'm going to get, oops, let me get these out of the way. Line that all back up nice and pretty, fold that out of the way. Okay, so the new number that I'll get, just go position by position. 0 or 0 is 0, 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 1 or 0 is 1, 0 or 1 is 1, 0 or 1 is 1, and 1 or 1 is 1. Okay, now this was 7 because 1 plus 2 plus 4 is 7. Now this is going to be even bigger because 1 plus 2 plus 4 is 7, plus 8 is 15. So if I OR 9 and 7, I'm going to get 15. Okay. So as a matter of fact, I think I'll go ahead and maybe fold this guy too. Fold them out of the way also. Okay. Get them out. And I'll move this down here. Okay. So remember what was in C was 9. Okay, what we just talked about. So so the result of this ORed with this is going to give me this, which I then assigned to this. Okay, so what am I going to see? I'm going to see 15. So that's how OR works. All right, so let me show you then. Let me show you the exclusive OR. Okay, so the exclusive OR, what that does, that will just zero out any matches, right? So exclusive OR 1 is 0, 0 exclusive OR 0 is 0, 1 exclusive OR 0 is 1, 0 exclusive OR 1 is 1. So 0 exclusive OR 0 is 0. Okay, 1 exclusive OR 1 is 0. 1 exclusive OR 0 is 1, and then 0 exclusive OR 1 is 1. Okay, so sticking with our example here of using 9 and 7, 0 XOR for short, 0 is 0, 0 XOR 0 is 0, 0 XOR 0 is 0, 0 XOR 0 is 0, 1 XOR 0 is 1, 0 XOR 1 is 1, 0 XOR 1 is 1, but 1 XOR 1 is 0. So then what number is this going to give us? It's going to give us a 2 plus a 4 plus an 8. So that should be 14. Okay, so let's go ahead and test it out. So D equals C exclusive OR 7, and then let's see out it. Okay, and we'll see the number that we get. And so there's your 14. Okay, so we got just one more of these things, and that is going to be not. Okay, so what the bitwise not does is it just takes every bit and flips them, right? So if I was to not C, right, that's what this is going to look like, then that's going to become 1, 1, 1, 1, 0, 1, 1, 0. Okay, so the not is pretty straightforward. Okay, so not 0 is 1, and not 1 is 0. That's it. That's all there is to it. So this is actually a unary operator. So I'll say D equals not C, and then we'll do C out int D, and we'll make that ANDL. Now the thing here is that the character data type can't hold a negative number, and when that lead bit is a 1, it turns it into a negative number, right? So maybe what we should do is just go ahead and create a variable, we'll call it E, that's actually an integer type. Okay, so we'll say short. Okay, so short E is equal to not C. Okay, so now let's go ahead and run that. Okay, and that should give us a negative number without doing the ones complement stuff. I wasn't sure ahead of time what it was going to be, but in this case it's negative 10. Okay, because again, if it's 9 and we not everything, there'd be, since it's a short, there's going to be 3 more of these things, or 8 more of these things. Okay, all of these zeros are going to get flipped to ones. this one's going to get flipped to a 0. This is going to get flipped to a 1, to a 1, and to a 0. So without going into 2's complement and all that stuff, what you get is you get a negative number because we flipped all the bits so that it was encoded as a negative number. Okay, so that is everything that I wanted to cover in this video. So yeah, I mean, if you are wondering about how the bitwise operators work in C++, C, same thing. There you go. You know, what do you have? You've got an operator for shifting left. You've got an operator for shifting right. And those are operators that they look just like the stream operators, right? Stream insertion and extraction operators. You've got bitwise AND, which is a single ampersand. So it's kind of like half of a logical AND. The logical AND has 2. The bitwise AND just has the 1. You got bitwise OR. Again, it's just the 1 bar instead of 2. You've got XOR, which is a caret. And then you've got the NOT, which is the tilde, which just flips all the bits. Okay, that's everything that I got for you in this video. As usual, if you're a student of mine, please feel free to shoot me an email or stop by my office hours. If you thought the video was good, then please consider giving it a thumbs up. If you thought the video sucked, then there's that thumbs down button as well. And please consider subscribing or supporting the channel in various ways. We got subscriptions, we got memberships that give you perks for as little as 99 cents. Other ways that you can support the channel, leave a comment, whatever. You know, really appreciate your feedback and your support. Anyway, that's everything. Thanks for watching, and we'll see you next time.